Have you ever wondered if there's a secret language hidden inside numbers? Beneath all the complex math, are there some fundamental building blocks, these core pieces that everything else is made from? Well, what are they?
What if I told you that every single whole number you can think of, 10, 98, a million, you name it, is actually built from a special secret set of core numbers? So what are these mysterious ingredients? The best way to think about them is like atoms, right? Just like water is made of hydrogen and oxygen, every single number is just a unique combination of these special number atoms. And yeah, you guessed it, they're called prime numbers. Okay, so what exactly lets a number into this exclusive club? Let's pull back the curtain and see the simple, kind of beautiful rule that makes a number prime. Here it is, it's this simple. A prime number is just a whole number that has exactly two factors, no more, no less. And those factors, they're always 1 and, well, the number itself. That's the whole definition. Let's see this in action. It'll make perfect sense. Take the number 11. The only whole numbers that divide into it are 1 and 11. That's two factors. Boom, it's prime. But now look at 9. You can divide 9 by 1, 9, and also 3. So, since it has more than two factors, it's not a prime number. See? Simple. Oh, and here's a super common mistake, so listen up. The number 1 is not a prime number. Why? Well, think about it. It only has one factor, itself. And remember, the rule is exactly two factors. So, sorry, number 1, you don't make the cut. So let's meet the first few members of this prime number club. We've got 2, 3, 5, 7, 11, 13, 17, and 19. And hey, you might notice something kind of weird. 2 is the only even number on that list. And that's because every other even number on the planet can be divided by 2, which automatically gives it an extra factor. All right, so we know the definition. We know what they look like. But if I asked you to find all the prime numbers up to, say, 100, where would you even begin? Sounds like a ton of work, right? Well, luckily for us, a genius from the ancient world came up with an amazing shortcut. To figure it out, we're going to have to go way back in time to ancient Greece. We're going to look at this incredibly clever method for spotting primes called the sieve of Eratosthenes. And trust me, it's more like a fun puzzle than a boring math problem. So the guy who invented this, Eratosthenes, was a total genius. I mean, this guy was born way back in 276 BCE. He ran the famous Library of Alexandria, and get this, he was the first person to actually calculate the circumference of the Earth. And as if that wasn't enough, he also gave us this brilliant tool for finding primes. So here's how his amazing sieve works. Picture all the numbers from 1 to 100 laid out. First, you just cross out 1, because we know it's not prime. Then, you circle 2, our first prime, and cross out every multiple of 2. Next, you move to the next number that isn't crossed out, which is 3. You circle it and cross out all of its multiples. You just keep doing that, and the numbers that are left standing at the end, those are your prime numbers. It's like a filter for finding primes. So cool. Now, you might be thinking, okay, that's a neat little history lesson, but why should I care about this today? Well, hold on, because this is where our little story about numbers takes a very modern and a very, very important turn. This is probably going to blow your mind. Every single time you buy something online, or log into an account, or send an email, you are being protected by an invisible shield. And that shield is built out of gigantic prime numbers. Yeah, these ancient mathematical oddities are the secret keys to our entire modern digital life. So the security of pretty much the entire internet relies on one simple, beautiful fact. It is really easy for a computer to multiply two huge prime numbers together, but it is practically impossible to take that gigantic answer and work backwards to find the two original primes that made it. That little bit of math is what's protecting your credit card numbers right now, all thanks to an idea someone was playing with over 2,000 years ago. To really get this, let's go back to that building blocks idea for a second. Let's just take a normal number and break it down into its prime parts, what we call its prime factors. Okay, let's just use the number 30. It's a nice, simple number. We know it's not prime, which means it has to be built out of smaller prime numbers. So, which ones are they? It turns out the prime atoms that build the number 30 are 2, 3, and 5. And if you multiply them, 2 times 3 is 6, times 5 is 30, you get right back where you started. Every non-prime number has its own unique recipe of prime factors, just like this. It's basically a secret code for every number. And that brings us to a final, pretty wild thought. Right now, the largest prime number we've ever found has over 24 million digits. That is a mind-bogglingly huge number. And it makes you wonder, with numbers that big and secrets that old, what other things are prime numbers hiding from us?